In this video, we're using trigonometry to find out the unknown side of a triangle. The first thing that we need to know is to learn how to name the sides of a right-angled triangle. We already know the name of one of the sides, the hypotenuse side. The hypotenuse side is the side which is furthest from the right angle. It's the longest side of the right-angled triangle. The other two sides are named relative to an angle which you know. In this triangle we know the angle is 35 degrees. Now the side that is furthest away from that angle is given the name the opposite side, and the other side, the side which goes together with the hypotenuse to make up the angle which you know, is given the name the adjacent side. After you've learnt the names of the sides of a triangle, it's time to learn three trigonometric ratios. The ratio of the length of the opposite side to the hypotenuse side is called the sine ratio. The ratio of the length of the adjacent side to the length of the hypotenuse side is called the cosine ratio, and the ratio of the length of the opposite side to the adjacent side is called the tangent ratio. Now we normally abbreviate these just down to three letters: sine, cos and tan. It's worth remembering these ratios. You can refer back to these notes at any time, but it will speed you up a lot in your calculations if you can remember that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. The basic steps involved in solving any trigonometry problem are: step 1, identify which sides are involved. Step 2, identify which of the three ratios connects together these sides. Step 3, write an equation which uses the ratio to relate together the sides and angle. And step 4, solve the equation. Let's have a look at how this works in a worked example. Step 1 is to identify which sides are involved. This question involves the opposite and hypotenuse sides. Step 2 is to identify which of the three ratios connects together the sides. Look back in our notes to where we've had the three ratios. We're looking for the one which connects together the opposite and hypotenuse sides. I think you can see that it's the sine ratio. Sine of any angle equals the opposite side over the hypotenuse side. Step 3 is to write an equation which uses the ratio to connect together the sides and angle. Now, the sine of any angle equals the ratio of the opposite side over the hypotenuse. So in this case, the sine of 35 degrees equals opposite x over hypotenuse 5.8. From there on, it's just a matter of solving this equation, shuffling it round until you end up with x equals. Let's try some examples together. So the first thing we need to do is ask ourselves which sides are involved. The first question involves the opposite and adjacent sides. If we look to our notes, we'll see that the opposite and adjacent sides are connected together by the tan ratio. In fact, the tan of the angle equals opposite over adjacent. In this question then, it's tan of 48 equals opposite x over adjacent 4.2. Now we need to change this round until we get x equaling something. At the moment it's x divided by 4.2, so we have to do the opposite of dividing by 4.2, which is multiplying by 4.2. Multiply both sides by 4.2. We'll have 4.2 times the tan of 48 equals x. Now I can get out my calculator and find out 4.2 times the tan of 48. Find our answer is 4.66. In the second question, it's the adjacent and hypotenuse sides which involve. We look to our ratios and we find it's the cosine ratio which connects together adjacent and hypotenuse. Cosine of an angle equals adjacent over hypotenuse. So in this example, the cosine of 37 is equal to x over 14. Shuffle it round to make x the subject by multiplying both sides by 14. And then we can take out our calculator. 14 times the cos of 37 equals 11.18. Sometimes the unknown value will occur in the denominator of the equation. Have a look at this next example. The question involves the opposite and adjacent sides, so that makes it a tan question. The tan of 68 equals opposite 12 over adjacent x. But to shuffle this round to make x the subject, we have to do a couple of steps. The first thing you might do is multiply both sides by x, but then you get x times the tan of 68 equals 12. We still haven't found out what x equals, so we need to divide both sides by the tan of 68. Doing this, we'll get x is equal to 12 divided by the tan of 68, which we can evaluate on our calculator. X is equal to 4.85 centimetres. Notice that the steps of transposition when you're doing this are a little different to what we had in the first questions. The last question is similar. We ask ourselves which sides are involved. It's the opposite and a hypotenuse. That makes it a sine question. We can say that the sine of 70 equals opposite 7.2 over x. We need to make x the subject of the equation, so we'll multiply both sides by x. X times the sine of 70 is equal to 7.2. Then divide both sides by the sine of 70. Our answer is x is equal to 7.66 centimetres.